let's move to the next terminology called ventilation-related hazards. And these are hazards arising from inadequate or poorly managed ventilation in workplaces, especially in underground mines or enclosed spaces. So proper ventilation normally ensures sufficient oxygen supply, removal of contaminants, for example, like the dust, gases and all that, and control of temperature and humidity. So ventilation related hazards also include oxygen deficiency, which talks about the insufficient oxygen levels leading to asphyxiation risk, and then toxic gas buildup, which also talks about the accumulation of harmful gases like carbon monoxide, methane, or hydrogen sulfide. Then dust exposure, which also talks about the increased risk of respiratory diseases such as the silicosis and all that. Heat stress is also there, and the rest. And then let's now come to fatigue. Fatigue refers to a state of extreme tiredness, or exhaustion caused by physical, mental, or emotional exertion. So fatigue significantly affects the performance and safety by reducing alertness, reaction times, and decision-making abilities. Common causes of fatigue include, prolonged work hours or shift work, which lead to, which is caused by insufficient, rest or sleep and all that. And then physically demanding task and the rest. Then let's now move to stress. Stress is the body's response to physical, emotional, or psychological challenges or pressures. Stress can be acute, that is short-term, or chronic, that is long-term, with potential impact on mental and physical health. So that is that on stress. Then we have the next terminology called isolation. And isolation refers to the physical or psychological condition of being separated from others. Workplace, in workplace context, you see, it can occur due to working alone in remote or confined areas, then lack of communication or support from colleagues and supervisors, and then social exclusion or lack of inclusions and all that. So let's take note of that too as well. Then the next terminology is PPE. You see, the PPEs refers to the specialized, gear or clothing worn by workers to protect themselves against hazards in the workplace. The PPEs act as the last line of defense to reduce the risk of injury or illness. And common types of PPEs, you have a lot of them being on the figure 11. Then we have the next terminology called Lototo, Lototo, not Loto. That is lockouts, tagouts, tryout. So Lototo is a safety procedure used to ensure that machinery or equipment is completely de-energized and cannot start up unexpectedly during maintenance or repair. So the lockout, you see, The process involves three key steps. That is, the first one is the lockout. So the lockout uses locks to isolate energy sources and prevent activation. Then the tagout attaches tags to indicate that equipment is logged out and should not be used. And then the try out also, you know, talks about testing the equipment to confirm that all energy sources have been successfully isolated. So the Lototo, protect workers from hazardous energy, for example, electrical, mechanical, or hydraulic, that could cause serious injuries and all that. Then we have the next terminology called Mine Safety Management Plan, MSMP. So Mine Safety Management Plan is also a comprehensive document that outlines how a mining operation manages safety risk to ensure the health and safety of the workers. So that is that. Then let's move on to the next terminology called emergency response plan. Emergency response plan, which is also a structured approach to managing emergencies in the workplace. It's, details the steps to be taken before, during, and after an emergency has occurred in order to minimize the harm and ensure a quick recovery. So that is that. Let's move on to the next one called incident reporting. You see, incident reporting involves documenting and investigating workplace incidents, including accident near misses or unsafe conditions and unsafe acts. This process typically involves, recording details, that is the time, location, and description of the incident, the root cause analysis, which talks about identifying the underlying causes to prevent recurrence, then corrective actions, which also deals with implementing measures to address identified risk, then compliance, which also ensures that legal and organizational reporting requirements are met. So incident reporting promotes accountability, improves workplace safety, and helps organizations to learn from their mistakes. Then we have the mine rescue team. The mine rescue team consists of, specially trained personnel who respond to emergencies in mining operations. So these teams are equipped to handle incidents such as, fire explosions, or, fire outbreaks, gas leakages or toxic atmospheres, cave-ins or roof collapse, trapped or injured miners, and all that. Then let's move on to the next one called ergonomics. And ergonomics is the study and design of work environment, tools, and tasks to fit the physical and cognitive capabilities of the workers. And ergonomics also aims to, optimize safety, comfort, and productivity by minimizing the risk of injuries and, fatal incident and all that. Then we have what we call the thermal stress. Thermal stress occurs when the body experiences discomfort or strain due to extreme heat or cold. It is a critical issue in the industries like mining, where workers may be exposed to harsh environmental conditions, especially underground mines. So thermal stress can also lead to heat stress. That is a condition such as heat exhaustion or heat stroke caused by high temperatures and inadequate hydration. Then cold stress, which also talks about issues like hypothermia or frostbite from prolonged exposure to low temperatures.
Okay.
Then let's come to lighting standards. You know that in the mining industries, during the night shift, even underground mines during the day shift, yes, so you go, your cap that you wear, your helmet that you wear should have a cap light. So um, the lighting standards refers to guidelines and requirements for appropriate lighting levels in workplaces to ensure safety and productivity as well. So these standards, cover illuminance levels, which talks about adequate brightness measured in lux for various tasks. For example, general work areas, precision task, and all that. Then glare control, which also talks about preventing excessive brightness that can cause eye strain or reduce visibility. Then we can also talk of color rendering, which also ensures that light accurately reflects colors, which is critical in task requiring visual accuracy. Then let's now move to occupational exposure limit, which also talks about the maximum amount or concentration of hazardous substance, for example, the dust, gases, chemicals that workers can be exposed to over a specified time period without adverse health effects. Then let's now move to the Mines Act. That is, I have mentioned even one of them during the background, during the safety regulations. I made mention of the LI 2182. So the Mines Act is a legislative framework established in many countries to regulate mining operations and ensure the safety, health, and welfare of the workers. The next terminology called ISO 45001. So ISO 45001 is an international standard for occupational health and safety management systems. So it provides a framework for organizations to, improve employee safety, reduce workplace risk, and enhance overall well-being of the workers. Then we also have the gas detectors. Gas detectors are just devices used to monitor and measure the concentration of gases in the mining environment or in a particular environment. So they are critical for identifying hazardous gas levels, ensuring worker safety, and preventing accidents. So we have different types of gas detectors. We have the phase gas detectors that are installed in specific locations to continuously monitor gas levels. And then you have the portable gas detectors. They are the handheld devices carried by the workers for personal safety. Then we have the single gas or multi-gas detectors designed to, detect one or multiple gases simultaneously, such as, the methane, carbon monoxide, hydrogen sulfide, and the rest. So gas detectors are widely used in mining, oil, and gas. and the industrial settings to prevent toxic exposure, explosions, and suffocation of the workers. Then we have dust samplers. Dust samplers are instruments used to measure and collect airborne dust particles in a specific area for analysis. So these devices help evaluate worker exposure to dust and assess compliance with occupational exposure limits. So we have various types of dust samplers. We have the personal dust samplers that is worn by workers to measure dust exposure during their shift. Then you have area dust samplers. That is normally they are stationary devices used to monitor dust levels in a particular location. Then you have gravimetric samplers. They measure the weight of the dust collected over time. Then you have real-time samplers. They provide immediate data on dust concentrations and all that. So in mining operation, dust samplers are critical for monitoring silica dust, which can lead to respiratory illness such as silicosis and all that. Then we have the seismic monitors. So the seismic monitors are devices used to detect and measure ground, movement caused by natural or man-made activities. So in mining industries, they play a critical role in monitoring rock burst, landslides, or roof collapses. They also assesses the impact of blasting operations. They also ensures, the stability of underground structures. Seismic monitors help, prevent accident by providing early warnings of potential ground instability, allowing time for, evacuation or corrective measures and all that. Now let's move to silicosis. And of course, I've mentioned silicosis throughout my presentation. And then silicosis is a lung disease caused by prolonged inhalation of fine crystalline silica dust, commonly found in mining, quarrying, and construction industries. It is a form of pneumoconiosis and results in scarring of lung tissue, leading to impaired lung infection. And then we have several types of, silicosis, which include chronic silicosis, which develops after long-term exposure to low levels of silica dust. Then accelerated silicosis, which occurs after short-term high-level exposure. Then you have acute silicosis, that is rapid onset after extreme exposure to silica dust, often fatal. So we have symptoms of the silicosis, which include shortness of breath, coughing, fatigue, and chest pains and all that.